Lesson 5, Part 1, Introduction to Scientific Notation. Encourage you to try these out on a calculator. If you do 12 raised to the 12th power, you get this really interesting number, 8.916100448. It's got a little times 10 to the 12th. Some calculators will have an E there. So this is obviously not a number between 8 and 9. This times 10 to the 12th actually means that we multiply by 10 12 times. If you multiply by 10 once, it moves the decimal one place. This is going to end up moving the decimal 12 places. It's got to move 3 more places that we will fill with zeros. So this is really 8,916,100,448,000. Now the last 3 digits aren't going to be zeros, but they did get rounded to be that. Ends up being a 13-digit number. If you try 2 to the 50th, it comes out as 1.427247,693 times 10 to the 45th. That's going to be a 46-digit number because it has to be, this decimal has to zoom that direction 45 places. And then 16 to the negative 20, that's like dividing by 16 20 times. 8.271806,126 times 10 to the negative 25. And that's it there. It's a very small number because we're actually dividing by 10 25 times. The decimal is going to move that way 25 times. So this is going to be you're going to have a bunch of zeros, 24 of these, before you get the 827. Okay? All right. One thing to notice here, which of these 3 is the biggest of the numbers? And you might think this one because it starts with 8.9, but it's actually this number here because it has the largest exponent. It's a 46-digit number, so it's going to be bigger just from that. Okay, I can use scientific notation to represent numbers. A number is written in scientific notation when it is represented as a product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So this is the factor right here. That needs to be between 1 and 10. Basically what that means is it's got one digit that is in front of the decimal. If you had 2 digits in front of the decimal, that wouldn't work for your factor. If you had 0 non-zero digits in front of the decimal, that wouldn't work either. Then this part right here has to be a 10, and the exponent has to be an integer, no fractional parts. Tell whether the number is written in scientific notation. Explain. Part A. 5.9 times 10 to the minus 6. Well, we checked 3 things. That number is between 1 and 10. It's got 1 non-zero digit in front of the decimal. This is a 10, and that is an integer. So this is, in scientific notation, the factor is greater than or equal to 1 and less than 10. The power of 10 is an integer exponent. So the number is written in scientific notation. Let's look at the next one. First, let's check the factor. The factor is actually less than 1. So this one is not in scientific notation. It doesn't matter if the other things work out. Since the factor is less than 1, it's not written in scientific notation. Determine which number is not in scientific notation. So we got to check 3 things on all of these. The coefficients, the factors, are all okay. This is just a negative number on part D. They're all between 1 and 10 if you ignore the negative. So let's check the 10s. They all have 10s. That's good. Let's check the exponents. 18 is an integer. 10 is an integer. Negative 1.5 is not an integer. That's a problem. 0 is an integer. So the correct answer here, B is not written in scientific notation. Okay, let's write numbers in standard form. The way I go about this when you're writing numbers in standard form, if you have a negative exponent, you want to move the decimal, making the number smaller. And if you want to make a number smaller, you will take its decimal and move it to the left. If you want to make a number bigger, you will take its decimal and move it to the right. You may have to fill in with zeros when there aren't already numbers there. So here's a couple of examples. Write 3.22 times 10 to the minus 4 in standard form. Well, you can see where the decimal was originally. Move it 3 places, making the number smaller. And each of those, well, the first one's got a 3. The other ones don't have anything there, so we use zeros to fill in. And we get 0.000322. Let's try another one. Write 7.9 times 10 to the 5th in standard form. The decimal is originally right after the 7. So we move it 1, 2, 3, 4, 5 places. And that's where it ends up. The 9's already there, but the rest of these fill in with zeros. So it is 790,000. Common mistakes I will see students make, they will think this number means number of zeros, and they'll just put 5 zeros on it. And that is not correct. It's 5 places. The 9 is one of those places. So this would be correct where there's 5 places moved, where 9 is the first one, and the next 4 of them end up being zeros because we didn't have any other digits there. All right, let's go through some more examples of writing numbers in standard form. 6 times 10 to the 7, I've got my 6. Decimal is right there. I'm going to move the decimal 7 places, making the number bigger. 1, 2, 3, 4, 5, 6, 7. It's going to move clear over to here. There are no numbers here, so I'm going to have to fill them in with zeros. So this is 60 million, putting in my 1,000 separators. Okay, next one, 9.9 times 10 to the minus 5. On this one, the decimal is originally between the 9 and the other 9. But since the exponent's negative, I need to make the number smaller. 1, 2, 3, 4, 5 positions. I'm going to fill in with zeros where I need to. This is 0.000099 as its answer. Okay, 1.285 times 10 to the 4. We start with the factor 1.285, and we move it 4 places, making the number larger. Looks like we have one place that's going to have a 0 put in it. This is 12,850. Okay, a couple more examples. These are the examples that go in the notes. Write in standard decimal form. Okay, 3.22 times 10 to the 6. I'm going to rewrite the factor, and I'm going to move 6 places, making the number bigger, and add zeros as needed. This is 3,220,000. Example 2. 5.3 times 10 to the minus 2. I'm going to write down the factor. Since it's a negative exponent, I need to make the number smaller by moving it 2 places. Fill in with 0. 0.053 is the answer here. Okay. Now just go through a bunch of problems quickly. 3.86, move the decimal 4 places, making the number bigger. It's going to have a couple of zeros. This is 38,600. 9.83765 times 10 to the minus 2. We're going to move the decimal 2 places, making the number smaller. It's going to be 0.098375. Next example, 1.03 times 10 to the 11. I'm going to do the 1.03 and move it 11 times. 1, 2, and it's going to go 9 more times, which is 3 sets of 3. And that's a total of 11 times. It's 103 billion. It's a pretty big number. Next example, negative 2.01 times 10 to the 0. Since the exponent's 0, I will move the decimal 0 places. It stays exactly where it is. This is just negative 2.01. Okay, next example. I'm going to go ahead and scroll down a bit here. Negative 9.83701 times 10 to the 15. Now it is a negative number. That's going to stay negative. I'm going to move this 15 places. 1, 2, 3, 4, 5, and 10 more places, which will all be filled with zeros. Actually, 15 is a multiple of 3, so I can just do these in groups of 3. I'm up to 9, 12, 15. That doesn't really look very good because it's on 2 different lines. Let me see if I can fix that up a little bit. Move, come on. Let's move that over. Still kind of runs off the page a little bit there. But it is a pretty big number, negative 9.8 quadrillion. 7.32 times 10 to the minus 12. This is going to be moved 12 places in that direction, which is going to give us 11 zeros, followed by a 7, and then a 3, 2. All right, 8.88 times 10 to the 8. This is going to be an 8, 8, 8. We've got to go 8 places from here. So there's 1, 2, 3, 4, 5, 6, 7, 8. 888 million is the answer there. And then one more quick example. Negative 3 times 10 to the negative 3. We start with 3. We move the decimal 3 in the direction making it smaller. We get 0.003 with a negative on it because it's a negative number. And that is it. An object with lesser density than water will float. An object with greater density than water will sink. Use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. So let's compare here the water and the brick. Is the brick greater density than the water? Well, they both have the same exponent, and you can look at their factors now if they have the same exponent. And brick is heavier, it will sink. You can actually see that down here. It's 1,000 compared to 1840. Now let's look at the apple. If we compare the exponents here, 3 compared to 2, 3 is bigger, water has a greater density, so the apple will float. And if you compare the numbers written in regular form, 641 is less than 1,000, so it's going to float. A dog has 100 female fleas. How much blood does the fleas consume per day? We're told a female flea consumes 1.4 times 10 to the minus 5 liters per day. We go ahead and multiply the amount each one consumes by 100, and we get this answer, 0.0014 liters of blood, which is 1.4 milliliters of blood. It's going to make the dog itch quite a bit too. All right, on the assignment for this one, scientific notation.1, you should, on number 1, you're going to practice writing. You're going to practice being able to tell whether it is in scientific notation. So this is yes or no. If yes, you're done. If no, why is it not scientific notation? Number 2, you're going to write the number in standard notation that's in scientific notation. Number 3, you're going to practice your exponent rules. 4, solve an equation for another variable. 5, find the area of a parallelogram. You have to use the Pythagorean theorem to find the height there. Number 6 is a review of function notation. Number 7, which of these stars has the highest surface temperature and which one's the lowest. So this is deciding which one's the biggest, which one's the smallest. And on number 8, this one deals with pH, which is related to exponents. The pH is actually part of the exponent of the hydrogen concentration.